All right, so 2.3 notes. All right, we have two things to talk about. Okay, you talk about union and intersection. These are complex inequalities. They require two, one or more. More than one inequality, okay? All right, we're going to talk about union first. Okay, union, or the word or, okay, means we must satisfy at least one condition. So we have to satisfy at least one. Okay? So, in this Venn diagram, this is called the Venn diagram. We use circles like this. Okay? Alright, we have two groups. We have a group that are funny and a group that are nice. But because we want to satisfy one condition, I can talk about everybody in the room. Because some of them are funny, some are nice, some are both, but everybody qualifies. Okay? That's what one means. I satisfy one condition at all. Alright, so in graphing then, we got to pay attention to what's going on in these graphs. Okay? So, we're going to look at these graphs and these graphs only right here. Okay? And we're going to write some more stuff here, so be ready to write. So the first one says, I want to be less than 3, which means I'm going to start over here with an open circle and go this way. And or I want to be greater than 0, which means we're going to start at 0 right here with an open circle and go this way. Okay? If we look at the condition of have to satisfy one condition at a time, then these numbers that are below 0 satisfy being less than 3. These numbers in the middle here, between 0 and 3, satisfy both conditions. They're greater than 0 and less than 3. And these conditions, these numbers up here, satisfy being bigger than 0. So every single number on the number line satisfies at least one condition. So this answer then, we graph it as one full solid line, and our answer is all real numbers. Okay? Everybody okay with that? Again, because we only have to satisfy one condition at a time, then we're satisfying one condition here, 2 here, 1 here. Every number in the universe does that, so all of them work. Okay, next conditions. Here we go. Okay? X is less than 0, or X is greater than 3. Alright? Okay, on this condition, I'm going to put one circle here at 0 and go less than. I'm going to put a circle at 3 and go greater than. And this is a normal OR graph. Okay, OR is because we have to satisfy one condition. I'm satisfying being less than 0 on this side of the graph. These numbers don't satisfy any conditions, but these numbers satisfy at least one condition on this side of the graph, so this is a perfectly fine graph. This would be my answer. I'd write it out like this. X is less than 0 or X is greater than 3. And my final graph would be exactly like this. I'd have circles going two different directions. Okay? You okay with that? Any questions on that one? Okay, good. Next thing, we're going to do X is greater than 0 or X is greater than 3. Now, on this one, we have an open circle at 0 and going up. We also have an open circle at 3 going up. So the question is, where do I start satisfying one condition? Okay? Well, down here below 0, I satisfy 0 conditions. There's no condition being solved down here. Okay? In between 0 and 3, I'm satisfying one condition, and from 3 to up, I'm satisfying two conditions. So, where do I start satisfying at least one condition? When X is 0. So your graph then, you only graph what works here. The 3 is encompassed. Because I'm going from 0 up, the 3 is part of that set. So I need to graph the 3 is. So I put an open circle here. I do not put any more circles in my graph. Okay? And my line goes all the way up through the top. my final answer on this will be x is greater than 0. That's the only thing we use for our final answer, because that's where we start satisfying at least one condition. Okay? All right. How do you feel about or now? A little bit confusing? Good. I'm going to put 3 more on you. So it'll be really confusing then. Okay? But again, keep this map around, and when you do your homework, map each one of your graphs before you put them in Alex. Okay? Do a little map, do a little precursor map. All right, let's go look at and. And is intersection. In intersection, you have to have all conditions satisfied. Okay? All right, that means we're looking for graphs that overlap. All right, we want them to overlap. That's what satisfies 2 conditions or more. So, according to our Venn diagram, the only people who are both funny and nice are these people right here in the middle that overlap. Those are the only people we're going to talk about. We're not talking about everybody else. So we just cut out a big chunk of people. Okay? All right, mathematically we do this. Ready for this? Here we go. First one, going to be less than 3. So I'm going to be up here at less than 3, circle there, going down. Greater than 0 means I put a circle at 0, and I go up. And I'm looking for where the graph overlaps. So I've got to satisfy both conditions. So down here I'm satisfying one condition. In between 0 and 3 I'm satisfying 2 conditions. And from 3 up I'm satisfying one condition. I want both. The only place I can graph then is between 0 and 3. So I put a circle at 0, a circle at 3, and I color in between the 2. And that's the only part I graph on my graph. I do not graph any farther than that. Okay? You should never have a line going from one point through another point like this. Should never happen like that. Okay, that's a no-no. Do not have 2 points on the graph, a line going through one of them. It doesn't work that way, okay? Not in these simple ones. It might be more complex or compounds, but not these. Okay? All right. So, second one. This is where we go. X is less than 0. And X is greater than 3. Okay? It's kind of the same one we did over here, by the way. Same exact we did over here. Less than 0, greater than 3. We're just putting up the and graph in the middle. So here we go. I have an open circle at 0, going down. I have an open circle at 3, going up. And where do I satisfy 2 conditions? It's open. Sorry, there's no equal there. I'm drawing really small. If you look really close, it's open. See, I'll show you really close. See, it's open? Kind of? Okay. Sorry. Okay? All right, but the question is, where do I start? Where do I satisfy both conditions? You don't, ever. So that means that there are no solutions on this one. Because there's not a spot on the graph that satisfies both conditions. Okay? All right. So as you might see, and is more restrictive. Okay? All right, last one. We have x is greater than 0, and x is greater than 3. So we have open circle at 0. I'll make it big and open. And going up. At 3 we have an open circle and going up. At what point do I start satisfying both conditions? Yeah, after 3. So the only one I have to worry about is where after 3 comes. So I just graph right here, open circle at 3, graph all the way up, and then my answer is just greater than 3. I don't put the 0 in there at all. I just use the 3. Because the 0 now doesn't matter anymore. because I'm not satisfying two conditions down there. Okay? All right, everybody okay with those little maps? Okay, you're going to see one of these 6 things, one of each of these in your assignment today. Okay, so keep this around. If you get lost, keep this around, and then as you do your problems, draw the little map. And I'll show you what I mean here in just a minute, okay? All right, so as we solve problems, okay, the or must be shown. If they have the word or in there, you got to see this, okay? You got to see the or. Okay? The and can be implied. Means it's not there, but we imply it's there. Okay? I'll show you what I mean in just a second. Okay? All right. So the first one, number 1. We're going to solve this, then we're going to graph it second. Okay? So we're going to solve this first. Here we go. I have an OR graph. So I know this is an OR graph. I'm going to solve this inequality over here, so please follow along and write this down. Divide both sides by 7. I got x is less than 4. Okay, there's the first one done. Second one, equal sign or inequality sign. Add 5 to both sides. I get 2x is greater than or equal to 16. Divide both sides by 2. I get x is greater than or equal to 8. Okay, and this is an OR graph. So I'm going to use these both things in an OR. Okay, so here's what I'm saying. On your paper, when you go to do your paper, before you go to your graph on Alex, do not do this yet. Go on paper right here and draw me a little graph. And give me a map of where it's going to go. Okay? These do not have to be very accurate. All they have to do is be kind of right. Okay? So like 4 is down here and 8's up here. That's all the more technical you got to be. Make sure they're in the right order. Okay? I want to be less than 4, so I'm going to put an open circle at 4 and go down. I want to be greater than or equal to 8, so I'm going to put a closed circle at 8 and go upwards. Is that possible for an OR graph? If you're not sure, look at your OR graph. Can I have an OR graph go away from each other? Yeah, that's possible. So I go down over to my graph now. I transfer this drawing onto my final graph. So go down here, find positive 4, put an open circle at positive 4, put a closed circle at positive 8, and the graph is going 2 different directions. There's your result. That's what you graph on Alex, okay? All right? Okay. Any questions on that problem? All right. This next one, this is going to kind of mess you up a little bit here, okay? There is not the word and in there or in there. See that? So this is what they call an implied and graph. When you have the 2 inequality signs and the stuff in the middle, this is definitely an and graph. Okay? Now, this is in 2 parts. So there's 2 equations here. The first inequality is right here. It's that part right there. The second inequality is this side. Okay? So you pull it apart and go 13 is less than 2x plus 3. And then you put and, gotta get in there, 2x plus 3 is less than or equal to 27. That's where you get your 2 problems from. And that stuff in the middle is used twice. Okay? Now we just solve these. So line minus 3 from both sides. I get 10 is less than 2x. Divide by 2 both sides. X is greater than 5. Now, do not try and graph this in that format. Remember, to graph, make sure you flip it around. So I've had a lot of people want to flip around and not change the sign, but you got to flip that X this side, you got to turn this sign around, put the 5 over here. You got to flip it around properly, okay? All right, that's graphable now. Second one. Minus 3 from both sides. I get 2x is less than or equal to 24. Divide by 2 both sides. I get x is less than or equal to 12. That's in graphable format already. So, and I know this is an and graph, so I have to have overlap. All right, so I do my little check here. I draw my line. I put my 5 down here and my 12 up here. Okay, I need an open circle at 5 and greater than. I need a closed circle at 12 and less than. And I'm looking for where there's overlap. Where's there overlap at? Yeah, between 5 and 12. So your final graph should be open circle here, closed circle here, and between the two. Okay? So when you transfer, I got to fix this graph. When you get this graph done, I got to fix this one. Kind of ran out of numbers over here. So I got to get up to 11 and 12 there. Okay, there we go, 11 and 12. So we have an open circle at 5, a closed circle at 12, and a line that goes between the two. And that's what I put on my graph. Okay? Oh, I forgot to tell you. Okay, when we write these answers, there's a way to write these answers, and you might have to type in some time. When you write this answer, you write it like this. You go x is less than 4, or x is greater than or equal to 8. That's exactly how you write the answer. Okay? And you can put it on either side. It doesn't matter which side you put it on. Okay, on the bottom one, we're going to do x is greater than 5 and x is less than or equal to 12. That's one way to write it. Or there's another way. If you want to put it back in the other way, put the 5 over here, point that towards the 5, put the x in the middle, point that towards the 12, the x, and there's your formal way to put it. So you can put it back in the non-and format, the combined format, or you can leave it apart. I don't care which way you put this. You'll probably do most of them like this, because it takes a while to get used to doing that. Okay, but if you have to write your answer, that's how you write it. Okay? You guys okay with that? Questions so far? Okay. Next page. Number 3 on the next page. Okay? All right. Okay. This is an and graph. You put and in the word for it, that's great. Okay? That makes a huge difference between and and or, so you got to make sure you know what it is. Okay, so take the first one, solve it. So minus 7 from both sides. I get negative 2m is less than 6. I divide both sides by negative 2. What's the rule on dividing by negative 2? What's the rule on dividing by negative 2? Flip my sign. I divided by a negative number, so I got to flip my sign around. Okay, so yeah, it's negative 3, but make sure I flip my sign. Okay? All right, now this other one, when I draw my line, I got to make room over here. So I got to have some room over here. Okay, so I'm going to minus 12 from both sides. And so I get 5m is greater than or equal to 25. Divide both sides by 5. And I get m is greater than 5, right? Okay, this is still and, so I have to have overlap. Oh, yeah. Why are you picking on me? Okay? All right, here we go. My little fake graph here. I got a negative 3 down here. Got a positive 5 up here. From negative 3, I've got to be open circle and going up. From positive 5, I got a closed circle and going up also. So, looking at my map, what do I got to graph for my final answer? Where does the overlap occur at? Yeah, Well, add 5 in after that, right? So my final answer should be a closed circle at 5 only, and one line going that way. Nothing else. Okay? So on your graph, go to 5, put a closed circle at 5, and go to the right, and you're done. Do not graph any more than that. Okay? Your final answer here will just be m is greater than or equal to 5. We do not put the 3 in there. It doesn't matter anymore. It's inconsequential. Okay? That happens the more you like it to. Okay? Okay, questions on those? You guys okay with that? I guarantee you guys, solving the problem is not going to be the problem. Getting on the graph properly is going to be the problem. So just be careful. Zach, Jess, quit throwing things back and forth to my room. Now you're going to be on YouTube forever. Okay? All right, here we go. Let's talk about this story problem. Okay? Megan, how do you feel like reading that to us? Yeah? No? Okay. Chase, what about you? Okay. All right. So, let's go back and dissect our story problem. What does at least mean? Perfect. Greater than or equal to 175 bucks. Okay? All right. How does he make his money? $10 per hour. That per means times, right? And we're using variable t, so we got 10t. And then what's this? Why is it minus? Okay, so spending money out of the account takes it out, right? Okay, there's your inequality. Now it says solve it. Add 35 both sides. I get 10t is greater than or equal to 210 divide both sides by 10, and I get t is greater than or equal to 21 hours. What I really want to know is, how do you get that job? Did you get 210? Well, 175 plus 35 is 210. Okay? All right. Okay. Not a bad job. Teaching kids to play video games. I couldn't do that job, though. I don't play video games. Nope, I don't play video games. Okay? Mario Kart is about the best thing I play. Sorry. Okay? All right. Let's read this one. Anyone do this one? Let's see. Sammy, how about you? Okay. Now, this story problem is kind of out of date because we don't do charges per minute now. But boy, let me tell you what, when phones first came out and kids were getting phones and they were being charged $2, 2 cents a minute and like 5 cents per text, parents were getting $3, $4, $5,000 phone bills, and they were not happy. Okay? Can you imagine you're giving your mom a $5,000 phone bill? How fast did you have your phone after that? Okay? My youngest daughter, when she got her first phone in ninth grade, the first month she had it, she had 15,000 text messages. Okay? She didn't have a phone the second month. It was gone. Okay? The biggest problem with that is that the majority of those text messages were after 10 p.m. at night. So she wasn't sleeping. So I took her phone away. Oh, no. $3,000 phone bill. Okay, I'm serious. There were people who are going bankrupt because of phones. Nowadays, we just have unlimited use. So we have unlimited text, unlimited minutes. So it doesn't matter. But back in the day when they charged for minutes and text, dude, there were people hurting. Here we go. What's this $27.50? Is that a fixed cost or is that a monthly cost? Or is that an hourly cost? What is that? That's fixed, right? So $27.50 per month. Okay. Additional fee. And it's really nice they put this in cents for you, but it's got that per minute on there. So we're doing 0.02 per minute. For at the most, what's the most he can be charged? What does that mean? Most he's been charged. You get charged over $183? So it's got to be what? Right, less than or equal to 183.44. Okay, let's get this thing solved. Minus 27.50 from both sides. Okay, got 0.02 M. And we got the calculator going to what this number is right here. 183.4. 155.94. Are we okay with that? Okay, divide that by 0.02. What was that? That's minutes on the phone? Okay, do me a favor. I'm curious. He divided that by 60 and you got 129 point what? 95 hours. Do me a favor, one more favor. Divide that by 24. 5.414 days. That's a lot of freaking time on the phone. Okay? I hope you're not on the phone 7,000 minutes. That'd be crazy. Okay, I'm done. All right? Turn this thing off.